Today I'm going to take you on a journey where we're going to show, or I would like to show you, what is the current state of 3D printing within the healthcare industry for implants, but also, well, all the tools that we use in surgery. So it's more the past, present, and future of 3D printing, what it could have and what is currently being done, where's the hype, and yeah, the reality check as well. But actually, before I start this presentation, I would like to stress something out that is very important, and I think that we, as well, users, should actually stress out more and more, especially if you operate these machines. There are ways to use them. You can be using them on a safe manner, but also unsafe manner, actually. And what I would like to show here with these two pictures is that we use powders most of the times, or even filaments if you come here across these holes. Most of the plastics, polymers, are actually toxic if you inhale them, when you use them, when you fuse them, so that can be dangerous to your health, actually. And the powders, well, they're very thin, they're very small in sizes, especially for metals. Well, don't start to work without gas masks or masks in general, because it could lead or into, well, maybe more potential clients for us in the future, but hopefully not injuries for you or your operators as well. So please take into consideration that these technologies can be dangerous for your health as well. Please use protection. In order to continue, I've been in this sector of additive manufacturing for quite a few years now, and what I've seen so far, or along the way actually, is that it has evolved a lot. A lot of hype attention, media attention, of course, a lot of technological advances and new materials, new applications, of course. And what we've seen also is that it has helped the business, it has helped the sector, the users a lot, the service providers, such as ourselves as well, with all the media attention, in a good way, but also in a bad way, because sometimes we had to re-explain everything to industrials in order to say, yes, you can print anything, but yes, it is not true at the same time. So thanks to, in 2012, 13, or even 11, there's been a lot of media attention, a lot of political lobby, a lot of, well, push of the technology in the field, and it is great, actually, that, for instance, for the consumers, that a lot has been done there, and that a lot is booming, actually. And if we think back at Euromold, when we were there as well, on the other events, TCT, it was not possible to see all these users, or machines, or polymers, or materials, actually. And thanks to this boost, it has changed a lot. But actually, there's also a reality check that has to be done for this sector. There's always the question is, can we actually print everything and anything, like it is always said in the media? Well, yes, but actually technically no. There's also a big difference, as a risk linked to that as well for this industry, because what I've seen so far, according to my experience, more and more industrials think that, well, you can print metal parts within 1 or 2 hours, which is not true. Or that, well, if you have these desktop printers, that this is all about 3D printing, which is not true as well. If we do a quick reality check as well, for people that are not familiar with this technology, actually, well, if you compare the smaller desktop printers, which are totally fine and amazing for prototyping or for small businesses, and you compare these to the actual industrial printers, there's a big gap, there's a big difference in terms of pricing, materials, but also productivity, actually, where one is meant for prototyping only, and the other one is more, well, can do that as well, but is clearly meant for production and serial production, actually, as well. So if you would compare that for things that you would be more familiar with, would be if you have your home printer, paper printer, 2D printer, and compare it to a printing press, for example, as well. It might be a bit pushy here, but this is one I would like to check out as well. I wanted to give you an overview of how it works, actually, or how we work within the medical sector in order to provide patient-specific implants. So it starts with the doctors, of course. We have to engage a lot of conversations, technical conversations, and the first thing we need, well, is actually patient data. So most of the time for surgery, trauma or oncology or other type of surgeries, we receive patient data in forms of 2D layers from a CT scan, a medical imagery system, actually. And from there on, well, we prepare a file, we do the actual design or the patient-specific design process, and then we select a manufacturing technology. It can be 3D printing, but this is what I want to stress out as well with my presentation today, to say that 3D printing is fine and it's nice to use, but it's not the only technology that should be used in order to provide a product or an implant. So there are others that are maybe more competitive as well or more suited to one application. 3D printing is one of them, and we do use this as well for metals, ceramics or polymers. And once you've chosen your fabrication method, well, the implant is produced and then it has to be finished. Most of the time it requires polishing, CNC milling, or even cleaning, coating, ceramic coating, and then it's sterilized and provided to the hospital actually. So these are the different steps. These steps, because this is the one of the questions we get all the time actually, well, they can be done in 24 hours, yes, but there's never such an urgency actually in this sector. Usually surgeries are, well, when we get the request, it is required within 2 or 4 weeks even. So it is never required to be printed within 24 hours. That has never happened so far, but we can deliver it. Here are some basics as well. So I've talked about the CT scan. It's a medical imagery system where you put a patient actually in this, well, sort of technology, and then you get the 2D images you see here in the back. It's a stack that we have to reconstruct a 3D file here, and we use different software as well in order to recreate something that is patient-specific according to the anatomy. Of course, you can render it here a bit. You can produce the anatomical model, but also shape implants into something that is actually physical, and then bring the models on the table of the surgeon himself, and he can use them to rehearse the operation or to actually study complex cases and adapt maybe one tool or the other. Our business is strictly focused on patient-specific. We don't deliver standard implants, actually, and that has a reason as well, because still today in current modern hospitals, surgeons would tend to use traditional methods where they would use a polymeric paste and apply it on the missing part of the skull, for example, while the patient is still awake or aware of what is happening. So that is somehow, well, methods of the 18th century, if you ask my opinion. And if you compare it actually to engineering, you would compare it to saying, well, let's say something like this, where you said you could repair a skull by these methods, where you just apply some polymeric paste on the surface, and then, yeah, it repairs it, it does the job. But is it fitting? Well, it gives something, a solution that is similar to this one, actually. And what we did is actually go away from that, use these modern techniques, and provide implants that are fully matching the patient's anatomy. And we believe that this is a model that is viable for certain sectors, certain aspects of the human body. It is not meant that 3D printing will replace all the manufacturing technologies. That is not true. That is a hype or a dream. Some techniques are well suited in order to fabricate an implant, and some are not. And especially for maxillofacial applications, 3D printing is best suited, actually. This is an example I took from actually what is available, what you can find on the internet as well, to show you as well that not only, well, 3D printing can address patient-specific, but also provide standard implants, actually. You have a case study where, for example, acetabolic cups, so these are meant to be used for hip implants, that can actually replace a certain modern or actual technology, because you can combine different functions. You can also bring some or add some other functions on the surface in order to reduce manufacturing steps and provide it all in one step, actually. But you see it here as well, still there's some CNC milling that is required afterwards. This is another example as well that is famous in the dental industry, actually, where we see here you don't have a mass production of one part, but you have a mass customization, actually, of parts. And these are done as well in metals on these 3D printers. And as you can see, well, today it is also possible on these existing machines to provide 450 customized crowns actually in 24 hours, which is pretty amazing. Another very good application is also the anatomical models in order to rehearse procedures, to select the best tools, to understand the complexity of a surgery procedure, and these are used before, after, and during the operation as well. These are massively used. I think this one is, was a case study also provided by Materialize. And moreover, what you can do is to create some sort of new materials, actually. So today, you can produce an identical implant that has been done in a traditional technique, but you can also go a bit further and be a bit more innovative about that aspect and create or generate some sort of new materials. So these are, for example, titanium, but in form of trabecular structures, re-engineered to avoid the stress shielding effect, for example. Bone, when it gets too, when the titanium implant takes over too much of the loads, actually, it resorbs the bone locally. And you want to avoid that or prevent that by actually adapting the material or the structure of the implant to the bone structure. And if you re-engineer completely your implant structure and you get to something that is trabecular as the bone structure that you can see here on the picture, you create some sort of new material with some sort of new elasticity modulus. And the hype and the dream, of course, of 3D printing is to provide, organs for tissue engineering, for actually, drug testing as well, or eventually for human body replacement parts. That is still a hype and dream, still not functional at all. And I hope if we do that, we think about it in a clever way, actually, so that we don't clone ourselves or print our next researcher or operator for our next 3D printing technology. So be careful about what you read about these topics. This is still very much a hype and a dream, a far dream. I also wanted to show what impact 3D printing could provide, actually, or this is a vision on the supply chain for the medical devices. I've been also talking to the big ones, the big logistics companies as well, and they wanted to know, can we actually print anything? So no. And can we actually replace everything we know so far in terms of providing a part throughout the world? So this is a slide here where you see the actual supply chain logistics, which is traditional to anything, actually, where you have a local mass production of the parts, which are mostly assembled anywhere else or maybe locally as well, and then it is shipped all over the world, distributed, stored in warehouses. And this is the dream or vision that is actually linked with 3D printing, where you would think of 3D printing to be used locally, print everything locally, manufacture everything locally, and then also, have very short distances in order to provide it to the consumers or industrial customers. So this is still a vision, it is still a dream and hype, so be careful about that, we're not there yet. But this has also a clear impact on the product itself, how we design a product, how we actually perceive a product, and this is how we do it with our surgeons currently as well. In a current production system, the industrial would think about something new, a concept, a new design. He would research the materials and maybe the process manufacturing technologies as well, adapt it towards the new product, and then ship it over through the traditional ways to the consumer or the surgeon, for example. But there, the industrial has the power of on deciding how it should look like or what the application should be like, what material it should have. But the user doesn't actually. There's no link. He can only choose what is available to him. And with 3D printing today, most of the time, the user is now able also to do some concepts to create something new, to innovate actually, to use also existing files that are already available on the internet, or co-create, as we say it as well. It is still manufactured at service providers, most of the time also locally if they have them. And then, usually as service provider, if you take some of the few that are existing on the market, they are suggesting what material should be used or what technology should be used. The user has no impact on that because he's either not aware of that or he doesn't have access to these technologies. But actually, here if you see, the impact is a bit shared. The consumer wants to more and more participate in the design, either of the manufacturing technology, but also of the product. And the industrial or the provider actually is helping him choosing the better fitting technology and material. And the hype and dream would be, of course, this called social manufacturing. This is maybe a new era where we will end up to, where you have the production facility and the end user that are on the same level, and they both decide on how a product should be. This is currently what we do with our implants as well, with the surgeons. We do the design directly in contact with them. Then of course, this concept could be locally stored in the cloud, or could be provided on the internet for people to actually purchase, or it could be designed even directly via the internet. Currently we have surgeons from all over the world. We don't go with our laptops, or we don't go with our suitcase there and decide with them how the end product should look like. We actually co-create with them on the internet with a communication platform, which is very well established. And this is more the social manufacturing that will, maybe come in application in a few years. Then of course there's still an aspect or questions about, who decides on how to research, who has the responsibility, where does the IP actually belong to, and what materials would be used, and who is consulting on these materials or technologies actually. So this is still pretty new actually. I also wanted to show a bit what we do in 1 or 2 slides, because it's also important to understand where we come from. So we only provide patient-specific implants actually to our surgeon. This is a patient from us. He still lives in Maastricht. We meet him from time to time, and he's called Mark. And Mike, unfortunately, he had a bicycle accident. So he had a car impact, and then his head impacted a tree actually. And this is what happens when you don't wear a helmet actually. So be aware of that as well. It's maybe a good point. And he had actually 5 surgeries on this side with traditional procedures and techniques coming from the surgeons. It never fitted very well. There were also some issues regarding mismatch and also rejections actually of the material itself, infections. And if you look Mark into the eye, you see that his right side is a bit sticking out because of the mismatch or the problem of the accuracy actually. And with 3D printing, actually the surgeon came to us and he said, I've seen that you're providing this service. Could you maybe help my patient? And in only 1 surgery, we provided actually a best fitting implant while pushing away the 5 previous interventions, which is actually pretty amazing if you think about it in terms of economical aspects as well. 3D printing for patient-specific implants are more expensive in the short term, but if you compare it to other traditional actually techniques, materials, manufacturing procedures, it is more economical actually. So this is what we do. We provide patient-specific products, not only 3D printed, but also other traditional procedures. Also cutting guides and placement guides. And we work together closely with our clients, our customers, who are the surgeons actually. And it's always a dilemma to understand what the surgeons want. He wants the materials or the products to be as close as the bone. Of course, most of the time biocompatible, and maybe eventually biodegradable as well. Of course, it has to be provided in very short delays. And he wants a fully finished product, of course. And in terms of what engineers think, they want a product that is manufacturable on a bigger scale, cheap, of course, so that we can hope to have better margins as well. An easy-to-use technology, pretty straightforward, and automated as much as possible. For some applications, we also came to a conclusion, or we also developed new materials. So we don't use commercially available materials only. We also develop our materials and procedures ourselves. And we came up with one of these new innovations, which is called CT Bone. And actually, it's a fully biodegradable ceramic material that has been researched on the commercially available machine, but which is fully open source. And this is also key to 3D printing. You cannot innovate with today's current manufacturing technologies if they are not open source for development. This is important. And well, we also made the step to grow a bit further, thanks to all the developments we have been doing at Xilloc this year. And we're also pleased to grow actually towards other sectors such as aerospace, automotive, tooling, and oil and gas. And I see my time is up, so I will stop here. Thank you very much.